Welcome. We want to take a look at what it means for a function to be one-to-one. So we have this nice formal definition. A function with domain A is said to be one-to-one if no two elements of A, that is, no two elements of the domain, have the same image. That is, the images are different whenever the inputs are different. Lots of different ways that we can phrase this. Some of these are going to be a little bit more enlightening or a little bit more helpful as we move forward to see if functions are one-to-one or not. Following this, we'll give a nice little image of what it looks like for a function to be one-to-one, similar to what we did for function composition and our original definition of function. So here's our definition. Equivalently, we may say each value of the dependent variable is associated to one value of the independent variable. So if we have f of x is equal to y, right? X is the thing that we're plugging in. That's the independent variable. Y, or simply f, is the dependent variable. We can also say each element or number in the range is associated to one element in the domain. This is the one that we really like. That actually is kind of giving us this last one here. We can also say each output has only one input. That's the same thing, just a rephrasing. Or we could say that if the outputs are equal, this implies that the inputs are equal. So this thing right here is probably of the most interest to us. That's going to help us. So this helps us show a function is one-to-one algebraically. So what does it look like for a function to be one-to-one? Well, let's consider the domain and the range of some function. We'll make it relatively simple. See here, 1, 2, 3. Just a small example here. And let's say that we have just two things over here. Call them 4 and 5. If we have 1 goes to 4, 2 goes to 5, if by chance we had 3 also goes to 5, we would have something that is not one-to-one. In order for a function to be one-to-one, we need to have each element of the range is associated to exactly one element of the domain. And the reason that we want that is because effectively what we're doing is we are turning these arrows around. When we turn these arrows around, when we find that inverse, 4 goes to 1, 5 is going to 2, and 5 is going to 3. Well, that's not a function. So what we have to have is we have to have this other thing over here. 3 goes to 6. So that way, when I turn the arrows around, 4 goes to 1, 5 goes to 2, 6 goes to 3. Now we get what we desired for that inverse to be a function, right? When I turn the arrows around, it is still a function. So this is what it looks like for a function to be one-to-one. F is 1-to-1. Excellent. We'll take a look at some examples of determining if functions are one-to-one in just a moment.